To see the real cost of any electric motor, you have to look beyond the purchase price. In this module, we will explore how you calculate the different factors that contribute to the total cost of ownership of an electric motor to find the true price that you are paying. The capital cost of acquiring a new motor is normally less than 3% of the total life cycle costs of the motor. The other costs are far more significant and must be taken into account when making purchasing decisions. The cost of running is about 70 to 95% of total costs and is based on the energy price per kilowatt hour and the annual running hours over a 20-year lifespan. Whereas the cost of not running is down to the cost of unplanned production stops. This is between 2 to 30% of total costs and is based on one major unplanned motor failure over its lifetime. Together, these three costs form the total cost of ownership and can be expressed as this formula. So let's take a look at how we calculate the individual parts. We'll start with the cost of running. As we saw in a previous module, an electric motor consumes more electrical power than the mechanical nameplate power would suggest, due to losses within the motor. Consequently, when calculating the cost of running, the motor's efficiency is an important factor. Let's consider a 315 kilowatt motor with a 95.5% efficiency, used in a continuous process in the oil and gas industry. The input power on which you will be charged is therefore 329.8 kilowatts. Now take an energy cost of 11 cents per kilowatt hour. Assume that the motor runs for 8,400 hours per year, and it has a typical lifetime of 20 years. The result is the cost of running the motor over its lifetime. Compared to the purchase cost, the cost of running is very high. Running costs can be reduced by choosing a more efficient motor, and we will take a closer look at this in the next module. Now consider the cost of not running. This is the cost of unplanned downtime in the production each year. A typical motor used in the oil and gas industry can cost an estimated $220,000 per hour if it fails for any reason. If we assume one major breakdown of 10 hours in its 20-year lifespan, then the cost of not running is shown here. As you can see, in a continuous process, one production break hour can cost over 10 times more than the motor that caused it. So what does this mean for the total cost of ownership? We'll find out in the next module.